Hello class, my name is Reinout from Landegem and my partner's name is Pikaso Dutta, and we are going to be giving the weekly update presentation for April 11th on our project, which is titled SPY and Sector ETF Pattern Recognition through K-means Clustering and Technical Indicators. Our academic advisor is Dr. Kashana. So for our project, we are going to be studying the volatility as well as the normalized graphs for the 9 sector ETFs that compose the SPY 500 index. We want to identify patterns in the volatility, the returns, and the normalized price graphs using two main methods. The first method we will be using is a time series clustering method, which I will be talking about in more detail, and the second method we will utilize is artificial neural networks, which Pikaso will talk about in more detail. The main question that we are trying to answer for our project is, which of the 9 sector ETFs delegates the SPY volatility and price movements the most? So this past week I have been working mainly on the written report of the project, while Pikaso has been working on the neural network method, so he will be talking about that later on. So here's a brief recap of the first method, which is time series clustering. So the top graph is for normalized prices, and the bottom is for return. So as you can see on the right, we have the cluster groups, which I talked about last week. The main idea from this is that the cluster groupings are very different for the normalized prices and returns clustering, which is something that we will be talking about in our report in more detail and for our final presentation as well. So for next week, we will continue to experiment with the number of clusters as well as adding and removing various ETFs to obtain a more precise pattern grouping. We will also both be working on the written report for next week. And now Pikaso will give an update about the neural network component of the project.
Now let us discuss on our second part of the project with neural network. So just an overview of this part of the project. We calculated VAR from ETFs, applied technical oscillators and indicators to get MACD, RSI and ADX, and considering them as our independent variable, we regressed them on VIX data using RNN LSTM model. So last week we got our model using the oscillators, RSI and ADX, tested on all the ETFs with various optimizers, and found that ADAM and SGD works best with our model. Now here we'll try using an indicator, MACD. The settings were the same from the previous record, but we got even poor accuracy compared to what we got last week. So here we see a comparative analysis of the oscillator's performance versus the indicator's performance on the basis of optimizers. So last week we used oscillators and we got SGD and ADAM as well, like one of the optimizers that we can use. But in case of MACD, we didn't find any such optimizer which can give us better results. So one reason for this poor result might be that MACD doesn't have a minimum and maximum value for oscillating, which means a specific number doesn't indicate any momentum for the signal unless they are transformed or compared with other values. So here we can conclude that the indicators are not going to work for this type of data unless they are squeezed to a definite range.